Let's follow the notes. So, exercise 3F is just about you identifying what's terminating, what's recurring. Terminating, when you're talking about decimals that are terminating, it means that the decimals have a finite number, meaning it stops. So an example would be something like 3.5, doesn't carry on, stays as 3.5. That's called terminating. If I have, say, 1.25, that is terminating because it's finite. Doesn't have any more decimals that carries on forever, all right? You could also have, say, 1.17845. It's still finite, even if it's more digits. Okay, it's just that if it stops, it's finite. Recurring, on the other hand, means that it goes on infinitely. What are some examples? 3.3 with a dot on the top. What does the dot on the top mean?
That 3 is reoccurring.
Good. 3 is reoccurring. If you have multiple digits, you can do a bar. So you can do 1.257 and you do a bar on top. What that means is it's 1.257, 257, 257, 257. Oh my God. And it goes on. That's what recurring means. Okay? So your fractions, when you convert them, this exercise is just teaching you how to change from fractions to decimals. So the conversion. So here's an example. First two examples. One is 5/8. What is that as a decimal? And 6/7. I chose these numbers because I know a lot of students memorize what half is as a decimal. They know what a quarter is a decimal. But if I change it to 3/7, not many people know how to get to that answer. Out of curiosity, half as a decimal is? What's half as a decimal? 0.5. And what's quarter? What's a quarter equal to? 0.25. Very good. Both terminating. So we can say that these are terminating decimals. How do you do 5/8? Here's the technique. To convert any fraction to decimals, you literally read what it says. This means 5, and that symbol here, over, actually just means divide. So you can actually type on your calculator if you didn't want to do the long division or short division. You can do 5 divided by 8, and it'll tell you the decimal. Let's do it by hand first, and then we'll check with the calculator to see if we're on the right track. So we're saying how many 8s fit into 5? That's what 5 divided by 8 means. So here I'm going to write 8. How many 8 fits into 5? And I'm going to put all the zeros in to give me some working space. So it's 5.0 for 5. Let's do this. How many 8 fits into 5? None, because it's too small. So that 5 now, the 5 units becomes tenths. So we carry the 5 over. Don't forget that decimal. So I'm going to put the decimal right there. The 5 units become 50 tenths. So how many 8s now fit into 50 tenths? 6, because 8 times 6 is 48. But then what's the remainder? 2, because 8 times 6 is 48. And you're missing 2 to make 50. So you carry the 2. Now, that's a 20. So how many 8s in 20 hundredths? 2, very good. 2 times 8 is 16. Remainder? 4. So you carry the 4 over. And that now becomes 40 thousandths. So how many 8s fit into 40? 5. Beautiful. And that's a remainder of 0. So that means this fraction, 5 over 8 as a decimal, is actually equal to 0.625. Therefore, it is terminating. It's not carrying on. Okay, so if I were to check on my calculator, if you type on your calculator and you couldn't be bothered doing it by hand, 5 divided by 8, 0.625. That's literally what the fraction means, 5 divided 8, and you can get your decimal. So if you're unsure, you can type on your calculator to check if you're on the right track. Okay? Try the next one. What about 6 over 7? 6 over 7 literally means, what is 6 divided by 7? Meaning how many 7s fit into 6? So here I would write 6.0 and I put as many zeros to give me some working space. And we do the same thing again. Let's go with someone here. Jacob, how many 7s fit into 6? None. Very good. 6 is too small. So it's 0, We carry the 6 units into the 10, so it becomes 60 tenths. Don't forget the decimal point. How many 7s fit into 60? Let's go with Attila.
I'm not sure.
Not sure, that's okay. 7 times 7 is 49, so we're getting closer. 7 times 8 is? Okay, and then 7 times 9? 63, so that's bigger than 60, so the number that fits in has to be 8. 7 times 8 is 56, so what's the remainder? 4, very good. So you carry the 4 over and you ask yourself again, how many 7s fit into 40? Let's go with... Yes? Mateo?
Me?
Oh no, you had your hand up. Oh. How many 7s fit into 40? Let's go with Zara. 5. 7 goes to 45 times because 7 times 5 is 35. What's the remainder? 5. So you carry the 5 over. Then you say, how many 7s fit into 50? 7, because 7 times 7 is 49. Now, what's the remainder if 7 times 7 is 49 and you want to fit into 50? 1. Very good. So you carry the 1. It's a very long one, actually. How many 7 fits into 10? 1. Remainder? 3. Then we go, how many 7s fit into 30? 4. 7 times 4 is 28, so the remainder must be? 2. Carry the 2 over. Then you do, how many 7s fit into 20? 2. 7 times 2 is 14, remainder? Oh, finally! We get that repetition. See how you end up with 60 again? That's a 60 there, that's a 60. So likely, it'll then be 8, 5, 7, 1, 4, 2. So this, if I carried on, it would have been 8, 5, 7, 1, 4, 2. There's a pattern there. That's a repetition. That's a 60 there and that's a 60 there. So the answer is 0.857142 with a massive bar on top. And that just means that it repeats 857142 infinitely, and it'll just keep going. So this is a recurring decimal. That's what you're doing in exercise 3F. Just those two. So one skill, which is division, and you just carry on. So if I did it on the calculator, let's see. 6 divided by 7, and it's rounded off actually. I should, let me change my settings. It should go on, let's go to float 12. We should see a pattern. There we go. So we start to see the pattern, it repeats. 857142, 8571, and then it's just rounded off here because my calculator can't go on beyond that. But it will just keep repeating. In that case, it rounded off the number to 3. Okay? All right. Last bit of today's lesson. So the first part is the main one, how to convert fractions to decimal. The second skill, rounding. I found that some students don't know how to round, so I just wanted to make sure you know how to round to 2 decimal places or 1 decimal place. Let's do this one. So how do you do rounding of decimals? When they say round to 1 decimal, you literally count 1 decimal. There's only 2 steps to it. Count the decimal and then check the next digit. If it's 5 or more, you round up that number. Okay? So here we go. Let's have a look at this one. 12.3845. If I want to round to 1 decimal point, this is my 1 decimal point. So your answer, usually we would write 12.3. That's 1 decimal point. But what do you have to do in the second step? You need to check if the next number is 5 or more. So let's check the next number.
Yeah.
Next number is 8. Is that 5 or more? Yes. So if it's 5 or more, you have to round that 3 up. So then the answer is truly 12.4. Okay, so you take the first digit, but you got to check the next number. Let's do the second one. What if I said round it to 2 decimal places now? So if you round to 2 decimal places, let's color it. You got 3 and 8. Those are my 2 decimal places. So usually you would say the answer is 12.38, but you have to check the next digit. Let's check the next digit. 4. So you take the first 2, because I said round to 2 decimal places. Check the next digit. Is that 5 or more? No, so you leave that as an 8. You don't change that 8. So the answer is still 12.38. Doesn't go up.
What?
If it was a 5 here, then that would have been a 3.9. If that was a 6, it would have been 3.9. If it was a 7, it would have been 3.9. As long as it's 5 or more, you upgrade that last digit. Let's go with the last one. What if I want you to round to 3 decimal places now? So let's color it in again. 3 decimal places. 1, 2, 3. So I got 384. My answer usually would be 12.384, but I need to check the next digit. My next digit is 5. So if it's 5 or more, you must round the last digit up by 1. So what would the answer be?
12.38.
Beautiful. That's how you round. Now, let's check part B. Now I'm going to start calling out students now. So I showed you 3 versions of the one example. Let's try B now. Rounding 0.97612 to 1 decimal place. Hamza, what would the answer be?
0, 1.
Very good, because you take the first digit, check the next number. That's a 7. So that means you have to increase this 9 by an extra 1, becomes 10. So you carry the 1 over. That's why 0.9 ends up being 1.0. Okay? What about 2 decimal places? Can I please have, let's go someone in the back, you Chen. Round 0.9761 to 2 decimal places. 0.98. So usually we put 0.97, that's 2 decimal places, but you need to check the next digit. That's 5 or more, so hence the answer is correct. Yu Chen said 0.98. You got to round it up 1. Last one, round 3 decimal places. Can I please have, let's go with Eknor. Very good, 0.976, because I have 3 decimal places, 976. Check the next digit. It's a 1. It's smaller than 5, so you leave it as it is. Still 976. Doesn't change. Another 3 students for the last one. Josh.
Oh my god.
8.14598, round to 1 decimal place is?
30,000.
8.1.
Beautiful. Take the first decimal point. Check the next digit. 5 or more, you round it up. But it's not 5, so that's why you leave it as 0.1. So it's 8.1. Very good. Next person, someone under this side. Let's go with Charlotte. 2 decimal places. 8.15. Let's see. So normally it's 1.4 because we take 2 decimal places, but we check the next digit. It's 5 or more, so that's why we have to round that 4 up to 1.5. That is correct. Well done. Last one. Let's go with Xavier.
Oh my god.
3 decimal places.
Where's Cook?
What would it be? 8 point.
1, 1, 4, 6.
Beautiful, because that's usually a 5. Check the next digit's 9, so the 5 has to go up by 1. It's 6. What about the last 3? Now the question, which I find very interesting, you guys can do 1, 2, and 3 decimal places, but when I put this in a test, I get a lot of random answers. If I want you to round it to the nearest whole number, it means instead of doing it to 1 decimal, 2 decimals, 3 decimals, it means to the nearest unit. So, let's do the first one. 12.3845. What is that to the nearest whole number, which means units?
12.
12, yeah. Because you look at the units column, I need a 2. But then you check the next digit. It's a 3. That's not 5, so that's why we keep it as 12. We don't take any decimals, so it's a whole number. So 12 is the correct answer. What about B? 0.9761, Mateo. Nearest whole number.
0.
Yes, normally it is a 0, but you got to check the next digit.
9.
Yeah, so it's a 9, so it's more than 5, so that means you have to increase this one by 1.
1.
Yeah, so the nearest answer is 1. So 0.97 is closer to 1 than it is to 0.9. Next one, what about 8.14598 to the nearest whole number, can I please have, let's go Garissa. It is 8. Because you take the 8, check the next digit, 5 or more, you round it up, but clearly 1 is too small. So the answer is 8. That's it. Those are the notes for 8F. Whatever's the remainder, easy. Remember, next session, you get the first half to do 8F. Second half, we do notes for 8G. Okay, so that's for tomorrow. I mean, 3, is it 8? Or 3G? Sorry, 3G. My bad. I'll start.